Okay, I guess it was working for me a second ago. All right, yeah, it's working for me now. So, hi everyone, my name is Pooja Gupte, and I will be speaking about effective web apps monitoring. And in my next slides, I'll show you what the agenda for the today's talk will be. So, in my last 3 years at Microsoft, I have been working on developing web applications and also worked on the monitoring side of it, the deployment cycles, deployment pipelines, and with that, I have gained some insight on what is the importance of monitoring and why we need it. And I would really like to share that with you all. I am also very passionate about cloud computing and all the greatness that comes along with that by having your code and infrastructure on the cloud. I'm also a volunteer with the Anita B. Seattle chapter here, and I'm also program coordinator with Indian Women in Computing, which is also Anita B. chapter. And this is a picture of me. I just thought I would share from the last conference I attended. This is a picture of me from Grace Hopper last year when we could all still meet in person. And it would have been really fun to meet you all in person. But I think we can make the most out of the platform that we have obtained here through Hopin, and Women Who Code team has done a great job at putting this whole conference together, and it's really awesome. So yeah, so basically this is going to be our agenda today. First of all, we'll establish a common understanding of what web applications are, and we'll dive into the common architecture components for a web app, and from there we will start into the it will be a good segue for us to start into the understanding the why we need monitoring and what is the importance of it and how it relates to business, right? Like what is the business side of it and how why the industry actually needs monitoring, and what are the different kind of metrics that that can be used in relation with web apps, so that you guys can use those metrics and define them for your purposes as well. And I will share about some tools and resources that can be used for web apps monitoring as well. So yeah, let's go into the web apps. So what is a web application, right? Uh, a web application is basically a computer program that performs a specific function for you by using a web browser as its client. All right. So web applications have been around since a while now, I guess. But even before World Wide Web came into picture, there have been developers who used Perl as their language to create client-side applications, and if you think about a common web app example that you have used, G Suite, for example, your Google Docs or using a Google form, that is a web application. That is an example of a web application. Also, using Microsoft Office 365, Office 365 is a type of a web application, and to take the step further of making the reachability of web apps to the users better, Dropbox app, for example, is an example of a modern web app which is also available to you through through mobile web, so that it can reach users in a more broader way. Um, so yeah, that's about web apps. And let's see what are the common architecture components in a web app. So over here you see DNS, which is domain name server, and you see load balancer, web server, client application, database server, CDN, and browser. So a user usually uses the application through a browser, and when he puts the website name, the URL into the address bar, it reaches the domain name server, which basically does the um, one-on-one mapping resolution of the domain, uh, host name to the client IP address, and that's how the user's request gets routed from the basically from the browser to the domain name server, and from the domain name server to the web server, where actually the business logic for the application resides. And this from here so web server basically has all the logic that when your client application that is served to you over browser, when it sends a request to a web server, it does all the calculation, it does all the transformation of business logic, and serves that request to you, serves that response to you on the client application on the browser when needed. And in modern architectures, we also have load balancer, which is basically the main importance of it is for scaling. So in terms of distributed computing, when there are multiple web servers and the expected number of users is large, load balancer does the routing of the requests based on the availability of the web server. So yeah, that's about load balancer. And database server, basically when web server needs to access some databases, there is essentially a SQL database or a NoSQL database server that can be used for the database purposes. One new concept that I recently learned is CDN, content delivery networks. So essentially, when the content is delivered to the user, and if it is mostly in larger applications, basically the delivery of the content is large, the HTML, CSS, the whole package of the uh, static components that gets delivered to the client application is large. In that scenario, the faster way of delivering those content over to the web is done using CDN technology, and an example of that is Azure Front Door. So over here, what you see is an example of modern architecture and how it all goes along. And like I mentioned, right, DNS is what comes first, and by when the user accesses a website, and then if there is a load balancer at all, then it gets routed to the load balancer, and from there to the web app servers, and to the database servers. This is essentially a very example of a very complex architecture. We don't need to go into so much depth of architectures right now, but this basically gives you an idea of how the complexity of modern architecture aligns together. And like I said, there is CDN, and yeah, cloud storage. I love cloud storage. So yeah. So this, I hope this gives you an idea of the modern architecture example. And so when it all ships together, what do you do when things go wrong, right? So in all the software companies, they have a release cycle planned, and when the product gets released, technically we want everything to work smoothly, right? All the pieces that we saw, we want them to work smoothly. And but why do we need monitoring at all, right? Yeah, because there are so many components involved, we want to observe and check the progress and the quality of the software, right? And when things go wrong, we want to understand and stay one step ahead of the consumer in some areas, by monitoring our application in and gaining a more observability of our platform, of our infrastructure. And so if I talk about how monitoring in general happens at different software companies right now. There is this new, there is not new, it's not new, it was originally developed by Google, concept of software reliability engineering, SRE roles. So SRE roles sometimes help in SRE engineers, just goal is sometimes for uh, developing those monitoring applications and gaining insights into the production resources. And sometimes startups and teams which are small, they don't have like a specific SRE engineer for doing all of those things. And we need to do that ourselves, and that's why we need to learn how we can do monitoring of our web apps ourselves, and how we can develop monitoring dashboards for it. So I guess the for those reasons, and uh, these are some of my favorite reasons why my team at Microsoft, we have come to the rescue of our monitoring dashboards because of these reasons. For some reason, our application has request failures, and there are thousands of exceptions going on, and we just made a new release, and some page is performing really low, like it responds at 30 seconds. 30 It takes 30 seconds to respond to the user request, and we have no idea why that happened and when it started happening. And there are dependency failures. So let's say you are using Cosmos DB as your dependency for gaining your data, or else you're using SQL Server from a third party resource, and you don't know if the reason why the response is not coming is because it's something wrong at your end, or if the dependency has stopped working, right? Or when we have deployment failure, and we want to figure out why the deployment failed, and we need to quickly investigate into those issues, right? And also for regression issues. So these are some of the common reasons why we need monitoring. And I am going to go a bit into the reasoning of why we need monitoring for a business, and because that will give you an idea of what's the purpose on the business side of it, right? And so when a company delivers a product to a customer, or essentially when they sign an agreement or contract of delivering the product to customer, there is a service level agreement. It's like a document that serves as the mutual understanding and expectations of how a service is going to perform between the service provider and the service consumer. And generally there are service level objectives that define the goal of how well the system is going to behave. And typically SLO for a web app would be like 99.99% of HTTP requests in a month succeed with 200 okay HTTP, a successful response, right? So generally we want the SLO numbers to be realistic, something which the product team can adhere to. And that's why we need to understand how we can define those um service level objectives using the metrics. And that's the reason why we need to define the metrics. I'm using the general term metrics over here, but in terms of service level agreement, they are called as SLI, service level indicators. SLI stands for service level indicators, which means what are the indicators that would define the reliability of your service to your customer and make them happy. There is also another saying that goes, reliability is defined by the happy state of a customer. And so when we deliver the product to the consumer, we need to define and decide those metrics. So now you will see some of the metrics that can be used used in terms. So number one is availability. What is availability in terms of a web app? And availability is in a web application is that is defined by the state when the application and it works as expected by the user. So when speaking about availability, we often refer to the ratio of the available time to the total time. Availability is described as a percentage, such as 99.9% availability. In this formula over here, like I just said, we can use this formula to calculate the availability of calculate the availability by taking the sum of all the successful requests divided by the count of all the total requests into 100. So for a site to have 100% availability it's an elusive concept because it generally hard to achieve in a production environment, if not impossible. So most providers often have an availability goal that they try to reach and maintain. So this is a formula that can be used for that calculation purpose. And but this is a manual approach which can you can also use there are I will dive into the automated ways of monitoring in few minutes. But in general, I want to give an idea of how you can develop your own availability monitor is basically by creating maybe a script or a web job that pings all of your applications URLs and takes the response takes the HTTP response code and keeps a track of the successful requests by the failed requests. So that's how you can do it manually. Let's see what is latency. So this is another SLI, service level indicator, that can be used for the monitoring purposes of your web app. And what is latency? It is basically the time taken by the time taken between the user's request and the web application response. So for example, I hit a URL and the time it took to respond was maybe 3 seconds, and the latency of that page is 3 seconds. um, that's what we mean by latency. And the next one is throughput. So what is throughput? Let's say you first of all, I have generally used the indicator throughput to take up to have observability into the dependencies that we are using for our web app. So number of requests produced per unit of time. So for example, 200 requests per second or 300 requests per second. That shows how quickly your dependency is going to perform, and can you rely on it, right? uh, yeah, that's the kind of the main purpose. And now now that we have seen all the indicators and the definitions of that, I want to talk about instrumentation and monitoring. Basically you basically when we talk about monitoring, I will quickly in next few slides I'll talk about what are the modern softwares you can use for automated monitoring and instrumentation. But these are the few things that you have to have in your mind while choosing your technologies for instrumentation and monitoring. So for example, infrastructure compatibility. Is your monitoring tool going to work along with all the resources that you have in your infrastructure, the web server or the log server or the application server? And also language compatibility. Let's say you are using Java or .NET, C Sharp. Based on your framework and language, can it easily get instrumented into your code base? And then lastly, the choice of automated versus manual monitoring. So while we talk about instrumentation and monitoring, the biggest thing is the biggest gateway to insights into your application is logs. And when we talk about web apps, there are generally two types of logs: application logs and web server logs. So application logs are generally the logs that are returned by your application code, and web server logs are the logs that are returned by the machine on which your application code is running. So I want to show you guys a demo of a React app that I quickly put together and deployed on Azure to show how monitoring can be done using Azure infrastructure. Azure is the cloud, is the Microsoft cloud, which I am going to show you. And later I will also talk about the tools that can be used for AWS and other clouds as well. So I am going to move. Okay. I hope you guys can still see my screen. All right, so yeah, here is my React app that I quickly put together to mainly show how I have done the instrumentation and monitoring using Azure. So first of all, I have used application insights package, npm package for npm package for the instrumentation that is also compatible with React. And yeah, I'm not going to go into the details of the code, but I am just going to show you how I was able to set up a tracking event using application insights. And uh, you it not only just like a track event, but it has many other options of like tracking an exception, tracking metrics, page views, and all the goodness that comes along with the package. And I have deployed my React app on Azure using Azure DevOps and by developing a release pipeline. This looks like a very simple architecture, but because it's a small app, but in the real world there would be, in the release pipeline there are much more complicated steps that go along with it. And this is my React app that I'm showing you, but our intention is not into the content of the app right now. Our intention is to see how what I'm obtaining by instrumenting my React app with application insights. So first of all, when I showed you that I have deployed my app, I deployed it on Azure App Service Resource, which is which is a resource in Azure on which you can deploy web apps, and it provides you with a URL on which your content is available. So, for example, this is my app, and because I have configured application insights instrumentation in Azure, you get this application insights blade, where we can see the we get into see the insights of our web app. So for example, right now my application is pretty simple, and because I'm using it, I have few views. And uh,
to interrupt for a bit, I want you to know that you have 5 more minutes and then 5 more minutes for questions. And if you can, please zoom in a little bit, because some people have some difficulties seeing your screen. And yeah, you can continue, sorry.
okay. Awesome. So I hope you guys can see a little bit better now. So yeah, application insights give me insights of what are the components in my application. And in terms of availability, I have set up this availability ping test. Like I mentioned a few slides back, we can do it manually. At the same time, these days modern softwares have capability of providing you the automated way of doing it, and this is an example of how application insights in Azure can provide you that insight. So right now my requests are all successful, and my application is performing at 100% availability, uh, mainly because it's a very simple app. um, and then because I have also configured instrumentation, I am able to dive into the logs of my application. So to quickly show you, when I deployed my application last night, initially it did not work, and but I was able to figure out what's going wrong because I had enabled application detailed logging through application insights. And yeah, that's the example of how logs can give you insight into what's going wrong and fix your failures. And this kind, I hope this kind of shows you the importance of importance and insight into monitoring tool. And I am going to jump back to my presentation here. So yeah. So yeah, we saw availability monitor in Azure Application Insights, and in general, for a complex application, we would get to see all the metrics into your application insights dashboard, and it also provides you insight into the detailed exceptions and request failures into the tools that are available. And yeah, so that was about using Azure on Azure infrastructure by Microsoft. But there are other options available as well, like App Dynamics by Cisco. And this is an example of how it can be used for complex architecture as well. And uh, I think most of the goodness comes should be similar, and based on your infrastructure, I guess it's up to the user to decide what they want to decide for instrumentation and monitoring. And in terms of AWS, there is CloudWatch, the service called as CloudWatch, that can be used for hooking your application and getting insights into your requests, server failures, and all the monitoring goodness that we talked about a few slides back. And yeah, so these are the other two options that are also highly used. And these so what I talked so far was really related to the application availability, latency, and throughput. But for latency, sorry, availability and throughput, so for latency, which dials down to the performance. For performance measurement, the two popular options that I know about are Lighthouse by Google. So I'm sorry, this image is really small, but basically when you run Lighthouse, both of these tools are available through an extension in your browser. It can be hooked into your CI/CD pipelines. It can be it can be run in your Chrome Dev Tools or Microsoft Edge Dev Tools, and from there, from over there, you would get like a performance score, and for all of the different categories of progressive web apps, accessibility, and the best practices that are followed, and get insight into how you can improve your latency. And yeah, so this is about tools for performances and accessibility insights. So, based on what we talked so far, the main resources are that are available are application insights, CloudWatch, App Dynamics, and Lighthouse for performance measurement. And yeah, so I hope this gave you a good idea about the why of monitoring and the how of monitoring. And I encourage you all to be your own monitoring hero, and uh, use all the technologies that are available according to your languages and infrastructure. And yeah, that's kind of about it. And I am open to QA.
Thank you so much, Puja. Your presentation was so great. There are a few questions. The first one is, can you please define regression?
Yeah, sure. So regression. So let's say today, let's say yesterday, my application was having a web page called puja.ts, Puja. Okay, on that, I had like five different components, five different lines of describing myself. But a new person checked in the code on the same application page, same JavaScript file, and now one line is missing out of that. Now the thing is that is a regression, because something that was working previously is not working now in your code, is basically a regression.
Thank you. I hope this answered your question. Another question is, can you recommend some resources to learn about what to measure and what information we should log or measure?
um I guess I don't know how we can share the resources, but in general you would want to you so one thing on top of my mind is you do not want to log users p1 security information, like the users username or email address, all of those things. That's something that you do not want to log. But what you can log is your application page name, function name, um, the API name, and errors, exceptions. Yeah, you can log all of those things.
Great.
I hope that answered the question.
Yeah, I hope, Sarah, that answered your question. Another one is, should logging be preventive or reactive? Logging everything might drown developers in a huge influx of irrelevant logs. How to identify key points of potential failure?
Yeah, I think that's a good question. Definitely, you don't want to log too much, because it becomes very difficult to navigate through the logs. But I think these days, and I think I forgot to really share through my demo, but what I also wanted to show is these days the logs you can run queries on your logs, right? So if you're so for example, in case of application insights, the backend that stores the application logs is Kusto, and I have lots of logs, but I think I'm able to also run queries on that and filter through my logs. At the same time, yeah, definitely you don't want to log everything. Like, you don't want to put like 10 lines of logs in a 5 lines of code application, right? So I think it really depends on the usage of the application and insight that you want to gain. You need to decide based on that.
I hope this answered your question. I think we have time for one more question, if anyone has any. If you don't, I would like to thank everyone for attending this talk. It was amazing. Thank you again so much. And the next sessions will start in 5 minutes. So you will have a 5-minute break before the other sessions start. Thank you again, everyone, for joining, and thank you, Puja. It was a great presentation.
Thanks so much.
Oh, there's only one more question if you want to answer. Is there a way to find out what is causing your web page to load slow?
um yeah, I really want to talk about that. So generally you can use your Chrome debugger, right? And from there, when you have all your network responses, I guess you can one thing is you can debug from there and see the response times of that. And you can there is this performance. I have not enabled Lighthouse for my Chrome debugger here, but when you add the Lighthouse for your debugger and run your application, it will give you a deep dive into every single static resource, how much time it took to load that, and also every single request, how much time it took to uh, respond. And I think even, yeah, so for example, even by default, the tools can give you all the timings, right? So yeah, you can use that as well.
Great. Thank you so much, everybody. You can reach out directly to Puja if you have any more questions. I think she will be happy to answer them. Thank you, everybody.
Thanks everyone.